So I want to do a couple of things here. I want to add some velocity to the points before they come into the simulation. So if you remember before, here in the initial data we were generating velocity there. We're pretty much doing the same thing but in the flip source. So I want, say, a little bit of force pushing it down. So I'm going to do minus 0.2. Okay, so you can see that I've got the visualizer turned on, so we can see the point trails. And for in the x-axis, going across this way, I'd like a wave motion. And to generate a wave, what we can use is sine, a sine function. So we call the function and we need some kind of seed inside it. So we can just drop in $f. If I do that and press play, you can see it heading over and we get a very slow wave. Okay, so I want something a bit faster than that. So what I can do to affect the speed is multiply it. It'll go a bit faster. Maybe a bit more, 10. Okay, so we get that nice flickering back and forward wave. And then if we multiply again after we multiply the whole thing, we get a kind of scaling factor. We see we have less velocity there. So it's not just the direction but the magnitude of the velocity there. Cool. And to make sure that so that should get imported into the flip solver. Now I also want to generate our viscosity here, and to make sure that that is read by the flip solver, if we head into the flip solver and then in volume motion back into the viscosity tab and just check this viscosity by attribute, and we're going to generate this viscosity attribute now, not one, just viscosity. And so in here after the flip source I'm going to drop in attribute create. There we go, and call it, maybe I'll just copy this, call it viscosity, and it is a float, default of 0, value 100, so essentially the same as what we already had. Okay, let's just make sure that that's working. Go here, maybe turn off the point trails, go back into smoothwise shaded. I'm not going to run a flipbook just to watch it. There we go. If I watch it from the side, you can see them getting this kind of wavy function, which is quite nice.